Welcome back, everybody, for another deep dive. This time, um, we're going to be looking at something really crazy.
Oh, yeah.
The use of quantum computers to simulate, like, cosmic events.
Right.
I mean, you hear that and you're like, wait a second, how can something
Yeah.
as small as a quantum computer simulate something as big as the universe?
Exactly.
So that's what we're here to unpack today.
Well, and what's so interesting about this research is that they're using a specific type of quantum computer,
Okay.
a D-wave quantum annealer, to try and model this event called false vacuum decay.
Okay, false vacuum decay.
Yeah.
All right, I'm intrigued. I need more information here.
It sounds very sci-fi.
Yeah.
But it is rooted in real physics.
Okay, so what does that mean?
Okay, so imagine the universe is like this perfectly smooth sheet of ice,
Oh, yeah?
and then all of a sudden a tiny crack forms in the ice.
Mm-hmm.
That crack represents a shift to a lower energy state, and in theory, that tiny crack could spread rapidly
Oh, wow.
and change the very fabric of the universe.
It's like a domino effect that can just like reshape reality as we know it.
Exactly.
Oh, it's kind of terrifying,
Yeah.
but also really, really cool.
Yeah, yeah.
Like I want to see that, but I also don't want to see that.
Yeah, well, and the crazy thing is researchers at the Jülich Supercomputing Center, they're using this powerful quantum annealer that's housed within what they call the JUNIQ infrastructure,
Okay.
and they're able to simulate this.
Okay, wait.
Yeah.
Hold on.
Yep.
Let's back up for a second.
Sure.
Because for those of us who aren't like quantum physicists,
Right.
can you explain what a quantum annealer is and how it works?
Yeah, so the basic building block of a quantum computer is a qubit.
Okay.
And unlike the bits in our smartphones or our laptops,
Right.
which can only be either a 0 or a 1, a qubit can be both at the same time. And that's called superposition.
It can be a 0 and a 1 at the same time?
At the same time, yeah.
Okay.
It's kind of like a coin spinning in the air
Mhm.
before it lands on heads or tails.
So it's like this multitasking marvel that can just be all these possibilities at the same time.
Yes.
But how does that help us simulate something as complex as like false vacuum decay?
So in a quantum annealer, these qubits are connected in a way that allows them to represent different potential solutions to a problem.
Okay.
And then they can carefully control the system and cool it down to really, really low temperatures. And the qubits naturally settle into the lowest energy state, which reveals the most optimal solution.
So they basically find the most stable configuration out of all these possibilities.
Right.
Wow.
And so in this case, the problem is to try to understand how false vacuum decay might unfold.
Okay.
And by using a quantum annealer with 5,564 superconducting qubits.
5,000 cool.
5,564, yeah.
Whoa.
They were able to model these conditions
Okay.
and observe the potential evolution of this event.
So they're essentially watching the universe potentially transform.
Yeah.
That's incredible.
And what's remarkable is they observe the formation of these like bubbles within rings of qubits.
Mm-hmm.
And that represents where the universe could potentially transition into this new state.
So they're like watching the universe like bubble up, like bubble by bubble.
Yeah.
It's changing.
It gives us a visual representation of how this theoretical event might play out.
That is so cool.
Yeah, it's a pretty big step forward in our ability to model and
Yeah.
understand
Yeah.
these really complex cosmic phenomena.
And this is like groundbreaking research, but I'm curious, like,
Yeah.
what other applications
Yeah.
does this have in cosmology?
Well, imagine being able to study black hole dynamics
Oh, wow.
in unprecedented detail, or simulating the interactions of dark matter.
Okay.
We could even delve into the conditions of the very early universe,
Oh,
right after the Big Bang.
it's like having a time machine
Yeah,
powered by quantum mechanics.
kind of, yeah.
That's awesome.
Yeah, really, it's like we're on the verge of unlocking these incredible secrets of the universe.
I know. It's so cool. And it seems like these applications go way beyond just like cosmology and understanding like
Oh, absolutely.
the really big questions, what about practical applications?
Right.
Like how will this affect like our daily lives?
Well, so think about all of the really complex problems that we face in like medicine or finance or even material science.
Uh-huh.
Quantum annealing, for instance, is incredible at finding optimal solutions from this huge set of possibilities.
So it's like a super powered optimization engine.
Exactly. And let's take like drug discovery for an example.
Okay.
Developing new medications right now is super long and expensive process.
Right.
But imagine if we could use quantum simulations to analyze like the interactions of millions of molecules
Oh, wow.
and pinpoint like potential drug candidates way faster.
That could be revolutionary, especially for diseases that we just don't have good treatments for right now.
Exactly. It could really speed up the development of new therapies and lead to breakthroughs in like Alzheimer's cancer, all sorts of things.
Okay, so beyond medicine, what other areas could benefit from this kind of computational power?
Well, you could think about optimizing logistics and supply chains on a global scale.
Oh, wow.
You can minimize delivery times fuel consumption.
Okay.
Even think about developing new materials with specific properties, like super strong but lightweight alloys for aircraft,
Oh, yeah.
or more efficient solar panels
Oh, good.
for renewable energy.
So it sounds like quantum computing could be a key driver in creating a more sustainable future.
It very well could, and the quantum computing market really reflects this excitement too.
Oh, really?
It's seeing this crazy growth.
Oh,
Some projections say it'll reach billions of dollars within just the next few years.
so it's kind of a booming field with a lot of players trying to get a piece of the pie.
Absolutely. You have major tech giants like IBM and Google, and then all these innovative startups,
Uh-huh.
and they're all pushing the boundaries of what's possible with quantum computers.
It's like a modern-day space race,
Yeah.
but with quantum computers instead of rockets.
Exactly. And it's not just about building bigger, more powerful machines either. There are all these different approaches to quantum computing,
Oh, well.
each with its own strengths and weaknesses.
So, like, what are some of the different approaches out there?
Well, so you have IBM and Google who are really focused on developing these universal gate-based quantum computers.
Yeah.
They're like the Swiss Army knives of quantum computing.
So they're like multi-purpose problem solvers.
Exactly. And then on the other hand, you have companies like D-Wave who are focusing on quantum annealers.
Okay.
Now, they're not as versatile, but they excel at solving these specific types of optimization problems,
Okay.
making them ideal for logistics, finance, and materials science.
So it's like having a specialized tool that's like really good at one specific task.
Precisely. And as this field keeps developing, we'll probably see even more specialized types of quantum computers.
Wow, that's interesting.
Each one tailored to specific applications.
Okay, so this all sounds really exciting.
Yeah.
But I imagine there are also challenges and limitations.
Of course, one of the biggest is scalability. Building and maintaining large-scale quantum computers is incredibly complex and expensive.
So it's not as simple as just like adding more qubits.
Not quite, no.
Okay.
And then another big challenge is error rates. Quantum systems are super sensitive to their environment,
Uh-huh.
which makes them prone to errors.
Right.
It's really difficult to maintain these delicate quantum states of qubits.
It's like trying to balance a house of cards on a windy day.
Yeah, pretty much. And then, of course, there's this big debate about quantum advantage.
Well,
Like, when do quantum computers actually outperform classical computers for practical tasks?
yeah, that's a big question.
We've seen some promising results, but achieving true quantum advantage across the board, still a big challenge.
So we're still in the early stages of development,
Yeah.
but it's a field with a ton of potential.
Definitely, we're on this incredible journey of exploration and discovery.
Well, it's certainly a lot to talk about. We've covered so much ground already, but there's one more area that I really want to get into before we wrap.
Okay, what's that?
Well, we've been talking about these quantum computers simulating the universe and solving these complex problems,
Right.
but it raises some interesting questions about the impact of this technology on society.
Mm-hmm.
Like, what are the ethical implications?
That's a great point, and a discussion that we absolutely need to be having.
It really is a conversation that we need to have now, especially, with this technology developing so rapidly.
Absolutely. And it's a multifaceted issue, too. There's a lot to consider here.
Well, and one of the things that I think about a lot
Yeah.
is this question of bias.
Right.
We know that algorithms can reflect the biases of their creators.
Mm-hmm.
So how do we ensure fairness when these systems are being used to make decisions that could affect people's lives?
That's such an important point. If the data sets that are used to train quantum algorithms are flawed or biased,
Right.
then obviously the results are going to be flawed and biased.
Yeah.
And this could have huge consequences, especially if these systems are being used in things like healthcare, criminal justice, or even loan applications.
Yeah, it's like that old saying, garbage in, garbage out.
Right, exactly.
But the stakes are just so much higher when we're talking about decisions that could, completely change someone's life.
Absolutely. And we need to be super vigilant about identifying and mitigating bias in these algorithms. And that means developing really robust methods for auditing and evaluating these systems, making sure that there's transparency in their development,
Right.
and just having these open discussions about the ethical implications.
So it's not just about the technology itself, it's about how we use it responsibly.
Exactly.
We need these safeguards in place to prevent these powerful tools from perpetuating or even amplifying existing inequalities.
Yeah, and that brings us to another really important point, access and equity.
Okay.
Quantum computing has the potential to completely reshape industries, and create this huge economic value.
Right.
But we need to make sure that those benefits are distributed fairly.
Yeah, we don't want to see a situation where only a few corporations or a few nations
Yeah.
have access to this technology
Right.
and everyone else is left behind.
Exactly. We need to think about how to make quantum computing accessible to researchers, entrepreneurs, communities around the world, regardless of their economic status or where they live.
It sounds like a really complex challenge. How do we ensure that equitable access
Yeah.
to something that, requires so many resources and expertise?
It's going to take a lot of collaboration,
Yeah.
a commitment to inclusivity. We need to invest in education and training programs, foster these partnerships between industry and academia,
Yeah.
create opportunities for international cooperation.
Well, it's encouraging to hear that at least these conversations are starting to happen.
Yeah.
That there is a growing awareness of these ethical considerations.
Right, and those conversations need to continue and expand.
Yeah.
We need to bring together such a diverse group of people, ethicists, social scientists, policymakers, technologists, to make sure that, we're all on the same page, that this is being developed and deployed in a way that aligns with our values.
Yeah.
And, our goals for a just and equitable society.
Well, this has been an incredibly thought-provoking deep dive.
Yeah.
We've explored this mind-boggling science behind quantum computing and its potential to totally revolutionize industries. And of course, all of these ethical challenges that we've been talking about that we need to navigate.
It's been fascinating, and, it really feels like we're just at the beginning of this incredible adventure.
Before we go, I want to leave our listeners with one final thought. As we stand here on the cusp of this quantum revolution,
Yeah.
we have a real opportunity and a responsibility to shape the future of this technology. And let's make sure that we use it wisely, ethically, and for the benefit of all humankind.
I completely agree. It's a future that we're creating together.
And to all of our listeners out there, thank you so much for joining us on this deep dive. If you enjoyed this exploration of quantum computing and all of its crazy implications, please subscribe, leave a